The basic function of a regulator is to control pressure reliably and consistently. You take the upstream pressure, you regulate it down to a downstream pressure, which then provides the system a consistent flow for it to operate.
So a pressure regulator is used in a lot of different systems to control either downstream or upstream pressure as other things within the system change, whether that's flow demand or temperature or usage of different components that are somewhere else in the system. The regulator works to maintain those pressures, whether it be downstream or upstream, as all of that changes. Pressure regulators are built with many different components. There's really three groups that drive pressure regulator performance. One is the control element, so that is the poppet and the seat. That controls how much pressure drop happens between the high and low pressure sides. Next is the loading element. Most often a spring, sometimes can be a pressurized dome of gas, but it's what the users interact with. So as we turn the handle one way or another, we're compressing the spring or allowing it to relax, changing the forces inside of the pressure regulator. Now, the way that the control element and the loading element talk to each other or know what position to be in is through the sensing element. So the sensing element is very often a diaphragm or a piston. It senses what's happening downstream, how much pressure there is, and allows the poppet to know just what position it needs to be in to optimize performance.
The key function of a regulator is to control pressure, and that's done by essentially a balance of forces within the regulator. So we apply a load, be that from a spring or a diaphragm and a dome with pressure inside the dome, which gives us a downwards force. The pressure coming into the regulator goes past a small poppet, which is in contact with the seat or nearly in contact with the seat. We have a very fine gap. That fine gap causes the pressure above the poppet to be reduced from the pressure below. That pressure above the poppet acts on a sensing chamber, a sensing element, a diaphragm or a piston is pushed up. That balances the force from the spring, which is pushing down. When we reach the balance point of those forces, we get a state of equilibrium, and then the regulator is working at its set pressure.
Because it would influence the customer's process, equipment, or analytical analysis depends on where the customer installs the pressure reducing regulator. Because customer needs a regulator to maintain the outlet pressure as close as the specification or requirement. And if the pressure reducing regulator doesn't function properly, it could be damaging the equipment that's sitting at the upstream of a pressure reducing regulator.
So when a regulator isn't operating optimally, that will affect the customer's end process. That could affect production, it could affect the quality of their end product, it could affect purge times, or ultimately you could have a component downstream that fails due to inconsistent pressures in the system.
Certainly the customer may experience downtime. I think if the regulator doesn't perform as the customer expects, they will see an interruption to the system in which the regulator has been placed. So our regulator is often a key element within the customer's system. It has to function properly to ensure the customer's system functions as it should.